All right, we're going to take a few minutes here to talk about what a parabola is again. We went over this in class today. I just want to make sure that we understand the different pieces of the equations and which equation we want to use depending on which way the parabola is opening. So what you're looking at here is basically what your notes look like, and pretty much everything is on here already. So there wasn't much room for you to put any of your own stuff. So what we ended up doing in class today was we made kind of this area right here in our notes the spot where we put our own parabola. So what I'm going to do is I'm going to just go to a new screen, but what I do in the next screen, I would just do in that area right there. So underneath, actually before I do that, let's just take a look at this definition of what a parabola is here. They have the parabola drawn, and then the other pieces that we talked about today were the vertex, which is right there, the focus, which is right there, and then this imaginary line called the directrix. Actually, the focus is an imaginary point too. It's not really a point that's on the parabola. But the definition of a parabola is that any point in the parabola is equidistant from the focus and the directrix. So for example, this point right here, it is the same distance from the focus to that point as it is from that point down to the directrix when we draw a perpendicular. So that's the definition of a parabola, all points that are equidistant from the focus and the directrix. The vertex is one of those points. So that distance from the vertex to the directrix and the vertex to the focus is one of the main parts of our equation, and that's P. P is the distance from the focus. Actually, I'm going to do this from the vertex to both the focus and directrix. That distance is P. So from the focus to the directrix would then be 2P. All right, so now I'm going to zoom in on this area a little bit more, that blank area, just by going to a blank slide. And I think in class today, basically what we did was we drew two parabolas, one that was opening up and one that was opening to the right. The one that was opening up we used as a reminder of what vertex is, and then those other pieces as well. We had the focus and the directrix. Try to make those a little bit more equidistant. So then the vertex is the midpoint then between the focus and the directrix. And we said that this distance here is P. Okay. There's an axis of symmetry. I just assumed you guys remember what an axis of symmetry is from geometry and from what we talked about earlier on in our quadratic functions chapter. There's an axis of symmetry that cuts the parabola in half. It is perpendicular to the directrix. We don't end up drawing that at all. But what we do end up using is, and I'm going to use this parabola on the right here, is through the focus there passes a chord whose endpoints are on the parabola. The length of that focus, the length of that chord is the focal width. Okay. The width of the chord that goes through the focus, and that chord is often referred to as the focal chord. I threw this one out there today because it's like nothing you've heard in a math class before. The Latin name is latus rectum, and we said that the endpoints of the latus rectum, okay, or I just refer to them as the LR endpoints. Those are the points that we'll plot on the parabola other than the vertex itself. So the only 3 points I want you to have on your parabolas are the vertex and those two LR endpoints, or the endpoints of the focal chord. Latus rectum sounds like you're more intelligent when you say that, so we say that more often than focal chord. But here's what's important. The focal width, or the length of the lattice rectum, the length of that focal chord, the focal width is 4p. It's really the absolute value of 4p because it's a distance. That width is 4p, which is we're going to see is also a part of our equation. So that means if this whole width from here to here, if that whole width is 4p, then from the focus to each endpoint of that chord, from the focus to each endpoint of that chord is then 2p. From here to here is 2p. And really it's the absolute value of 2p. Because as we'll see, p can be negative, but that's just going to be distance there. So that distance is 2p. So the equation, and this is shown in this diagram here, the equation will help us to determine whether the parabola opens up, down, left, or right. Okay? If you are dealing with an x squared equation, and we said if the vertex is at the origin, then we don't need to worry about this hk. If the vertex is at the origin, the equation is x squared equals 4py. So we'll see where that 4p, that focal width, is right there in our equation. X squared equals 4py. Second, let me get rid of that. Is the equation if the vertex is the origin. If the parabola is opening left or right, as in the bottom two pictures, then we have this equation. Okay, and that equation has y squared instead of x squared. All right, so the top equation, we have x squared, and y is linear. And in the bottom equation, we have y squared, and x is linear. If the vertex is the origin in this case down here, then we have y squared equals 4px as our equation. So these are the equations if the vertex is the origin. Those are our two, much simpler obviously than if you have the h and k to worry about. So then it comes time to figure out whether your parabola is opening left or right. Okay, so let's say you know it's x squared, so you know it's opening up or down. Let's start with that. If it's opening up or down. How do you know if it opens up or if it opens down? Well, that value right there, that value right there is going to tell you. Because if that value is negative, that means that p is negative. And if p is negative, then this is going to open down. If p is positive, it's going to open up. But if you're dealing with a y squared parabola, that's either going to open left or right. If p is positive, it'll open to the right. And if p is negative, it's going to open to the left. So the combination of whether it's x squared or y squared and what our value of p is, if it's positive or negative, that'll tell us how our parabola opens. So our first example, and I'm not going to go through this whole example, just as a real quick reminder. Our first example, once we put this into its standard form, we said, well, p is positive, and it's a y squared. And the combination of those two things tells us that it's going to open to the right. Okay, y squared tells us left or right. Positive, p being positive tells us that it opens to the right. All right, now let's take a look at that last example. We talked in class today about the relationship between the focus and any sort of rays, whether they be light rays, sound rays coming out of that parabola. Anything coming off the focus, let's see if I can go back here, anything coming off the focus is going to come off the parabola on a line that is parallel to the axis of symmetry, or perpendicular to the directrix. So as we move this focus in or out, we can adjust how these beams come off the sides of the parabola, and that's how you get the beam of a light fixture, the beam of a flashlight to have different widths when it hits the surface, because it's coming out of the parabola, or the coming out of the light that is formed by a parabola, the housing of the light. It's coming off that at a different angle because of the placement of the focus. So our example here, I'm going to get rid of some of this here. Our example here, it talked about this. It basically calls it a glass parabola. I picture like almost like a big dish, like a satellite dish. It says, out of this glass parabola that is used to collect solar energy, we have the rays that come in, and we place the boiler here at the focus. We want to know, basically, what the depth of this dish is. Now, a lot of students get too caught up on the focus here, the focus being the boiler. It says here the sun's rays are reflected from the mirror toward two boilers located at the focus of the parabola. That's not really related to the depth of the parabola. The depth of the parabola is right here, okay, according to our diagram here. And to make things simple then, what I've done, and I don't know if this is start with this kind of, start from scratch here. Okay. What I've done is I've decided to make the vertex of this parabola. So I'm using this as my parabola right here, or as my vertex. I've made that the origin. Okay. And then this is our x and y axes there. So we know that the boiler is 10 feet from the vertex. It says the width is 37 feet. The focal length, the distance from the vertex to the focus, is 10 feet. All right, well, that's just what we've been calling P the whole time. So I have right here, the fact that the focal length is 10 feet tells us that P is 10. We know that P is 10. The other thing we do is say, well, if our vertex is the origin, we don't need to use H and K. We can just use our equation x squared equals 4py. Okay, our diagram has this opening up, so I'm going to use x squared. And then I can put our value of 10 in for P, and I'm going to come up with this nice little equation that I can use to pretty much answer any question that could come at me here. If they wanted to know the focal width, it would be 40. That's that 4p value right there. But if you notice the depth of this here, if I just draw this across here, actually, and that's not straight, but here's my focus here. It's actually outside of the dish itself. So the depth only goes to here. Okay, so we can't just say that, oh, this is that 10 feet is the depth. That's kind of like a common misconception in this problem. That the depth is, oh, it's 10 feet. They tell us what the focus is. No, we actually have to go through and find out. So we need to use this. We need to use this 37 feet that they give us. The width of this is 37 feet. So from here to here is 37 feet. So basically what we know is right there. We know a point on this parabola. The point on this parabola that we know is not 37. It's going to be half of that 37, or 18.5, comma, y. We don't know what y is. We just don't know what that y value is. But we know that that's a point on the parabola, and any point that's on this parabola will work in the equation that we came up with. So if we put in 18.5 for x, we're going to be able to solve for y. And now I erased that before. I don't even know if I have this on my sheet here. I can do this. I don't have my calculator with me. That y is going to be equal to 18.5, excuse me, yeah, 18.5 squared, whatever that value is, divided by 40. And if you calculate that out, you get about 8.56 feet. So that's the depth. And it makes sense that that's shorter than the 10 feet because we can tell that boiler is outside that dish, so that the depth is a little bit less than that. So I wanted to take a minute to go through that. We didn't get to that example in our second Honors Algebra 2 class today, so I wanted to make sure that you guys saw that. And then we did a little rundown of the parabolas. If you have any questions, shoot me an email.